In this video, we're going to look at what the composition of the early atmosphere was and what the composition of the current atmosphere is. We're then going to explain how the early atmosphere changed into the current atmosphere. So we're going to look at how the levels of carbon dioxide decreased and how the levels of nitrogen and oxygen increased. Finally, we'll describe the evidence that we have for how these changes occurred. So the Earth's atmosphere has stayed the same for about the past 200 million years. The Earth's atmosphere is mainly made up of three different gases. These are oxygen, nitrogen, and carbon dioxide. The atmosphere contains 21% oxygen, 78% nitrogen, and 0.04% of carbon dioxide. So after the Earth was first formed, it was a ball of molten rock. Over millions of years this cooled, and then this formed the Earth's crust. We've just said that the current atmosphere is made up of three main gases: oxygen, nitrogen, and carbon dioxide. We're going to look at how much of these gases were present in the Earth's early atmosphere. In the early atmosphere, there was no oxygen, only a little nitrogen, and lots of CO2. The vast majority of the atmosphere was made up of carbon dioxide. There was a small amount of water vapour also present in the early atmosphere. This then cooled and condensed and formed the oceans we have on the Earth today. We're now going to summarise what we've talked about and compare the early atmosphere to the current atmosphere. In the early atmosphere, the landscape was mainly volcanoes. Now the landscape is mainly dominated by oceans. In the early atmosphere, there was no oxygen, but in the current atmosphere, there's about 21% oxygen. This means that the amount of oxygen has increased. In the early atmosphere, there was only a little bit of nitrogen, but now nitrogen represents the main gas in the atmosphere at about 78%. So this means that the amount of nitrogen has increased. In the early atmosphere, the main gas was carbon dioxide. It made up the majority of the atmosphere. In the current atmosphere, it only makes up a small proportion, about 0.04%. So the carbon dioxide has decreased. You need to be able to recreate this table in your exam. You need to know what the landscape of the early Earth was like and the landscape of the current Earth. You need to be able to describe how much of each gas was present in the early atmosphere and give the percentages for the amount of gas in the current atmosphere, and say how those gases changed between the early and the current. We're now going to look at how the concentration of nitrogen increased. As well as the water vapour being released from the volcanoes, which eventually formed the oceans, volcanoes also were releasing nitrogen gas. Nitrogen gas is very unreactive, so over millions of years from being continually released by the volcanoes, it slowly accumulated in the atmosphere, and this is why the amount of nitrogen slowly increased. There are three main ways in which the concentration of carbon dioxide increased, and they all involve the ocean. The carbon dioxide from the atmosphere dissolved into the ocean. You need to make sure you use the word dissolved. You can't say absorbed or went into. The carbon dioxide from the atmosphere dissolved into the ocean. The dissolved carbon dioxide then reacted with some other ions, and it formed sediments on the seabed. Marine animals also use this dissolved carbon dioxide to make their shells. So for example, the shells of like sea snails have got the calcium carbonate, this sediment inside of them. When these sea animals died, they were covered in layers of sediment, which over millions of years compressed them and turned them into a fossil fuel. All three of these methods trapped the carbon dioxide in the ocean, either as sediments or as the fossils of dead sea animals. This meant the carbon dioxide is trapped at the bottom of the ocean and can't escape back into the atmosphere. The way oxygen increased was all based around plants. Once plants evolved, they began to photosynthesize. This involves taking in the carbon dioxide and releasing oxygen instead. So the amount of oxygen in the atmosphere increased. This is also a way in which carbon dioxide decreased, but in the exams you only get the marks for talking about photosynthesis in terms of oxygen increasing. If you're writing a long answer explaining how the atmosphere changed, you can't get the marks twice. So make sure you reference photosynthesis in terms of how the amount of oxygen increased. We're now going to look at the evidence which leads us to believe the atmosphere has changed in the way I've described throughout this video. The first piece of evidence is volcanoes. We can look at the gases released by volcanoes today, and they'll be the same gases which were released millions of years ago. So we know if volcanoes release, for example, carbon dioxide and nitrogen and water vapour, it makes sense that those volcanoes would still be releasing those gases millions of years ago. So we can use those volcanoes to predict what gases would have been in the atmosphere millions of years ago. We can also have a look at similar planets to Earth in our solar system, for example Mars and Venus. Those planets don't have life on them, and we know the early Earth didn't have life, so we can make an assumption that the compositions of the atmospheres might be similar. We can also look at rocks to tell us how the atmosphere was millions of years ago. For example, iron oxide, a type of rock, only forms when there's enough oxygen in the atmosphere at certain oxygen concentrations. This means if we find some iron oxide rock, we can use special techniques in chemistry to determine how old that piece of rock is. We then know at that point, millions of years ago, so for example, if the iron oxide rock was 300 million years old, we know there must have been some oxygen 300 million years ago. So we can date rocks, we can see how old they are, and we can use that to determine what gases were present in the atmosphere. We can also look at fossil samples. So we can look at what species we've got fossilised and look if they required oxygen or not. If they required oxygen to live, there must have been oxygen in the atmosphere at that point in time. If we look at some examples of bacteria which didn't require oxygen to live, it's a good indication that there wasn't any oxygen in the atmosphere at that point in time. Finally, we can't be completely sure how the atmosphere changed because we haven't got enough evidence to be 100% sure. In this video, we've stated what the composition of the early atmosphere was and compared it to the current atmosphere. We've explained how the early atmosphere changed into the current atmosphere, and we've discussed the evidence that we have for these changes.